All right, here's the part 2 of the Trig Unit 8 test solutions. And I think we stopped on question number 9, so we'll come over here to question number 10. Now, this one, as you can see, I've kind of given a hint, is going to involve that Pythagorean identity there, sine squared plus cosine squared equals 1. But how are we going to get to it? We have two fractions, kind of like the last problem. We have two fractions and we want to subtract them. So whenever we're subtracting fractions, we have to get the denominators to be the same. So we take the first fraction and we just multiply it by the denominator of the second fraction. So that first fraction, top and bottom, we're going to multiply by cosine x. And then the second fraction, we'll multiply the top and bottom by the denominator of the first fraction. And again, this is, you know this, that you're really just multiplying by another fraction that is equal to 1, so you're not changing the value of the fraction. You're multiplying it, essentially multiplying it by 1. But of course, and you should know that, but there were some mistakes on the test where people tried to do things like squaring both top and bottom of a fraction. You can't do that, so you can't just do anything you want to a fraction to manipulate it. But you can multiply the numerator and the denominator by the exact same thing and still have the same fraction. Okay, so what we end up with in the denominators are cosine x times 1 minus sine x. So cosine x times 1 minus sine x. So the denominators are the same, which means we can now do the numerators. We can do the operation here, our subtraction with the numerators, and just kind of ignore the denominators, sort of. The denominator for our answer is going to be what that common denominator is. Okay, so let's do the numerators. The first one, cosine x times cosine x, is cosine squared x. And I'm going to put that in parentheses, and then I'm going to bring down the minus sign, because I want to keep track. You always want to keep track when you're subtracting something from something else. If there's more than one something that's being subtracted, we're going to have to distribute. So just kind of keep that in mind, looking down the future. So we're going to do sine x times 1 and sine x times sine x. So we get sine x minus sine x squared, or sine squared of x. And then again, we're going to distribute the negative that's kind of in between the two fractions, so that each of these are going to be the opposite of what they seem to be right now. So it's minus sine x and plus sine squared x. So let's rewrite that. That's still our denominator, or I'm sorry, that's our numerator, and the denominator is the common denominator. I won't write that again yet. Save that one for later. So I have my cosine squared of x, and then minus negative is plus sine squared of x. And also minus that single sine of x. Okay, and I'm going to change the order here, and I think you can see why. Cosine squared of x plus sine squared of x, that's just equal to 1. So that becomes 1, and then minus the sine of x. Okay, keeping in mind, all this time we've just been dealing with the numerator of my final big answer to the fraction. The denominator is that common denominator that I developed at the beginning, cosine x times 1 minus sine x. And now, wouldn't you know it, we can see that we have a 1 minus sine x in the numerator and 1 minus sine x as a factor in the denominator. We can cancel those out, and we're left with 1 on top, cosine x on the bottom, and that is the, let's see, that's the secant, right? the inverse of the cosine. Hooray! Number 10 down. Slide on over to here to number 11. Kind of the same deal going on here. We have two fractions. This time they're being added. And we want to get the denominators the same. So to be able to do this addition, we need to get the pesky denominators to be the same. This is going to be a lot bigger pain. But if we can recognize an old friend of ours, remember this a plus b times a minus b. And remember, when you FOIL that all out, it ends up equaling a squared minus b squared. Okay, that's a difference of squares, the factored form of the difference of squares. And if we recognize that that's what we have here, 1 minus sine x, 1 plus sine x, it's the same thing, one time being added, one time being multiplied. And what we're going to do in order to get those denominators to be the same is we're just going to multiply them by each other. Then we can almost just kind of say, yes, that's what I'm going to do, without actually writing it all out. So I'm going to multiply the numerator and the denominator of the first one by 1 plus sine x, and the numerator and denominator of the second fraction by 1 minus sine x. And when I multiply the denominators, so I'll do the denominator first this time. When I multiply the denominators together, I get a squared minus b squared, the first term squared, which is 1 squared, minus the second term squared, which is just sine, oops, missed the I in there, sine squared x. Okay, so that's my common denominator. And then the numerators, I've written it out there, but you can see it's a lot easier to deal with. 1 plus sine x times 1 plus 1 minus sine x times 1. So there's my numerators kind of all put together in one line. Because it's an addition problem instead of a subtraction problem, it's not as important that I put a parenthesis and put parentheses in there. Alright, so let's just do that addition. 1 plus 1, combining like terms, we end up with 2. And then sine x minus sine x, that's 0. So we're left with just 2 on top. And then 1 minus the sine of x squared, or sine squared of x, on the bottom. Okay, so now that should kind of ring a bell a little bit. We should think, oh, sine squared, where do we see that? That's our Pythagorean identities. And the identity that deals with sine squared is the one sine squared a plus cosine squared a equals 1. So if I wanted to kind of put this sine squared and the 1 together, I would subtract sine squared a from both sides. I'd end up with cosine squared a equals 1 minus sine squared a. Okay, and that's what we have, 1 minus sine squared a, so we'll just write in its place, in our fraction in the denominator, cosine squared a. Oops, only it's, the variable is x. So cosine squared x. Alright. Now we need to remember cosine, cosine is the reciprocal of the secant. So if I have a cosine in the denominator, in fact, maybe I should kind of just think about this for a minute. So I have a 2 on top. We could separate that out, just say that's a 2 over 1, and then 1 over the cosine squared of x, which is really 1 over cosine times 1 over cosine, if you wanted to think about separating it out like that. And then we would have, well, this is equal to the secant of x, this is the secant of x, and so we have 2 times the secant of x times the secant of x, or 2 secant squared x. Again, you probably don't explicitly write all that out every time. You probably do a lot of that mentally, and that's fine. Okay, this is the one question on the test from this section that was not super simple. So it was 2 times secant squared of x. I can't think of a way to simplify that further, so that's the end of that one. Oh, let's see, where's number 12? So question number 12. Oh dear, this one is crazy. Let's think about this for a minute. We have cosine 2x minus 1, sine 2x. Now, when I see that, I don't think, oh, well, it's cosine 2x and sine 2x. They're kind of the same thing, so we're fine. Instead, what I think, or maybe I could think in terms of cosine over sine, that's the inverse tangent or the cotangent. That would be a way to think about this, but I think a better way to think about it is when you see that 2x, that's code for the double angle identities. So you see that 2x, that should remind you of these identities here, the double angle sine identity, and then we have 3 versions of the double angle cosine identity there. So I've written them out for you. So let's see, we can do the sine part. That doesn't require a lot of thinking. I'll just take and write that identity out. So the sine 2x is equal to 2 times the sine of x times the cosine of x. Okay, that's easy. Now we have cosine 2x, and there's 3 choices. And as I look at this, I'm looking here at the original fraction, and I see there is this minus 1. So I'm going to be subtracting 1 ultimately at the end of all this. Whatever the cosine 2x version I use, I'm going to subtract 1 from it. So when I look down at these 3 versions, I think, well, which one of those gets simpler when I subtract 1 from it? And notice that the first one, there's like subtracting 1 from that would not simplify it in any way, just kind of complicate it further. Second one, subtracting 1 would give me minus 2, because it already has a minus 1 in it. So when I subtract 1, I get negative 1 minus 1, which is negative 2. So it doesn't technically make it a simpler, whereas this third version, I have a 1 minus something else, but if I subtract a 1 from that, that's going to cancel out that 1 that's in the identity. And so that one will get simpler if I use that version. So that's the version I'm going to use. All right, 1 minus 2, if I knew how to write, it'd be awesome, sine squared x. All right, so 1 minus 2 sine squared x, that's the cosine 2x identity, minus 1 from the original fraction, and that's going to cancel, right? The 1 and the minus 1 cancel each other out. And here's the mistake I made when I did this. I forgot that minus sign in front of the 2 sine squared x. So you don't forget that. There's a minus sign there, and you're going to see how it's easy to forget that as we move along here. Notice now that in my numerator, all I have is one thing, one group of multiplication thing. It's negative 2 times sine squared x. And in the denominator is just one grouping of multiplication. It's not, there's not like things being added anymore, which makes this a lot easier to reduce, right? Because we can cross off the 2, we can cross off the sine x on the bottom, and one of the sine x's on the top. But we have to be really careful that we don't forget there's still that negative sign. I didn't cross off the negative. It's negative 2 divided by 2 is negative 1. So it's negative sine x, 1 sine x, over the thing left on the bottom was the cosine x. And of course, I hope you remember that the sine divided by cosine is equal to the tangent. So I'll just say negative tangent of x is the final, simplest version